Alright, so welcome back to your favorite inorganic YouTube channel. Today I'll be looking at some multiple choice questions in differentiation. Alright, in differentiation. So you want to look at how to evaluate this particular problem. You want to look at how to evaluate this particular problem. So this alright. So this particular problem, we want to evaluate it. So this we can use the method of substitution. Alright. So let u equals 2s cubed plus 2. Alright. So let's differentiate this particular function. So when you differentiate this, you have 6s squared. Alright. And then we make the s the subject. So when you make the s the subject, you are going to have the x equals du equals 6x squared dx. Now we need the x. So we say the x equals du over 6s squared. Alright. So now we substitute the x into the function and then replace this one with u. Alright. So now we have u power 5 s squared. Then the x is now du over 6s squared. Alright. So this particular s squared cancel this particular s squared. And then we have u power 5 du all over 6. Alright. And this finally, we can factorize the 1 over 6 out. So we have u power 5 du. Alright. And then this 1 over 6, when you integrate the inside, u power 5, then we have u power 6 over 6. Alright. Plus the constant of integration. Alright. So this we have 6 is 36. Alright. So we have 1 over 36 u power 6 plus c. Alright. So this is the final solution. But then we said u should be equal to 2s cubed plus 2. So we have 1 over 36 into bracket 2s cubed plus 2 power 6. Alright. So this becomes our final evaluation of to this particular problem. Alright. So now let's move on to question number 2. Question number 2. So this is 1. This is 1. So let's go over this particular evaluation again. When you are asked to evaluate this integral function, let u equals the function inside the integral. Let u equals the function inside the integrand. Alright. So when you let u equals 2s cubed plus 2, then you differentiate that particular function. So when you differentiate 2s cubed plus 2, you have 6s squared. Alright. And then you make the s the subject. When you make the s the subject, you have du over 6s squared. Alright. And then you go and substitute the dx into the function, and you have u2 to be this. Alright. So when you substitute, after our evaluation and simplification, we have this. So when you integrate u power 5, then you have u power 6 over 6. Alright. Then you multiply the scalars. Alright. So we have 1 over 36 u power 6 plus c. But earlier on, we said u should be equal to this function. Alright. So that is what we substituted to have this particular solution. So this is our final evaluation to this particular integral. Alright. So question number 2. Question number 2. We have to solve the integral of 1 over cos x cot x dx. The integral of 1 over cos x cot s ds. Alright, so now to solve this particular problem, you have to simplify the integrand. And we know that cot s is equal to cos x over sin s. Alright, and we already know that this is cos x cot s. Alright, so we have cos x cot s is equal to cos x over sin s times cos x. Alright, so this becomes the denominator, the simplification to the denominator. Alright, so this, when we simplify further, we are going to have cos squared x over sin x. Alright, so this particular function cos squared x over sin x, we can rewrite this as 1 over sin s times cos squared s. 1 over sin s cos squared s. Alright, and then let's go back to the actual function. The actual function is 1 over cos x cot s. Alright, and then this, we have the denominator to be this. Alright, so we are going to have 1 over cos squared s over sin s. Alright, so when you simplify this particular one, then we are going to have sin s times 1 over cos squared s. Alright, and we know that 1 over cos squared s is equal to sec squared s. Alright, so 1 over cos squared s is equal to sec squared s. Alright, and we also know that since this is sec squared s, then we can rewrite this as this particular function as sin s times sec squared s. Alright, so now this is the simplified integrand. Alright, so let's put this integrand into the integration function. Alright, so now this implies that sin s sec squared s is equal to tan s sec s sec s. So now you can find the integral of this particular function. Now the 1 over cos x cot s has been simplified to this particular function. Alright, so now we can say that the integral of tan s sec s, ds will be equal to sec s plus a constant sec k. So when you have this particular function 1 over cos s cot s, we have to realize that cot s is the inverse of tan, right? So we have cos s over sin s, and moreover cos x cot s is written in this form. So we multiply the cos s over sin s times cos x. All right. So we're going to have cos squared s over sin s. Right. Now we take 1 over that particular function we are having. Right. And we have 1 over cos squared s over sin s. And this simplifies to this form. All right. And our earlier identity, we know that 1 over cos squared s is equal to sec squared s. All right. So we put in those identities and now we have this. All right. So this is now simplified to this. So sin s sec squared s is equal to tan s sec s. So this is our simplified integrand. So now we are going to integrate this particular function. All right. So when you integrate tan s sec s, we are going to have sec s plus a constant say k. All right. So now let's move on to question number 3. Let's move on to question number 3. So question number 3 says we should evaluate this particular function. We should evaluate this particular function. Integral of 2 power x dx. All right. So before we can evaluate this particular function, we need to find the function f of s such that this particular function equals. So the actual problem is we need to find the function f of x such that this particular function is equal to f of x plus a constant, say c. All right. And to find this particular function f of x, we need to integrate the function inside the integrand, right? And this is 2 power x. All right. And we recall that the integral of a power x, with respect to s is equal to a power x over ln x. Is equal to a power x over ln a. All right. Where a is a constant, where a is a constant, where a is a constant. So in this case, our a over here will be 2. Our a over here will be 2. So here, a is equal to 2. So let's apply this particular knowledge of integration to this particular function. All right. So we now see that the integral of 2 power x dx is equal to 2 power x, which is the a is the 2 and the exponential function the x, all over ln 2 plus a constant of integration. So when you integrate 2 power x dx, the actual function that you have to get is 2 power x over ln 2 plus c, right? Just from these particular assumptions. All right. So that's f of x is equal to 2 power x all over ln 2. All right. And this particular thing is equal to 2 power x over log 2. We already know that ln is the same as log. All right. So ln 2 is equal to log 2. All right. So therefore, f of x is equal to 2 power x over log 2. 2 power x over log 2. So this becomes the function when you integrate 2 power x dx, this becomes the outcome 2 power x over log 2 or 2 power x over ln 2. Alright, so next problem is, let's move on to question number 4. Question number 4. We are given this particular problem. Alright. We are given this particular problem. And we are to simplify this particular integrand. This is a definite integrand, and we have to simplify it and find the value of what? K, right? So this particular function, we can split the integral into 2 parts. We can split the integral into 2 parts, and we have all right. So first, calculate the integral of s cubed. Calculate the integral of s cubed, and then calculate the integral of k. All right. So when we calculate the integral of s cubed, we have integral of s cubed is s power 4 over 4. Right. Then the limits are 1, negative 1 and 1 plus. When you integrate this particular function, you are going to have 1 outside okay. You know that this is a constant. K is a constant, so we bring it out, and when you integrate k with respect to k, you have k. All right. So this we have negative 1 equals 10. All right. So here, when you simplify this, you are going to have 1 over 4 minus 1 over 4, right? Plus, when you simplify this as well, you are going to have 2k equals 10. You are going to have 2k equals 10. So this part gives us 0 plus 2k equals 10. So 2k is equal to 10. And then we have k equals 5. So the value of k in this particular problem is equal to 5. All right. Therefore, or hence, k is equal to 5. K is equal to 5. So now, let's move on to problem number 5. Question number 5. Question number 5. Question number 5. So question number 5 goes like this. 5s4 root of s5 plus 9 ds. All right. 5s4 integral of 5x4 over square root of s power 5 plus 9. All right. So for this particular integrand, we can use a substitution method. All right. We can use a substitution method. So let's see. We have to let s power 5 plus 9 equals u. So let u equals x power 5 plus 9. All right. So this particular problem, we can easily work it out. All right, since we are using the substitution method. All right, so now let's determine the derivative of u. So the derivative of this u, the u is equal to 5s4 5x4 dx. So the s is equal to du over 5s4. All right, so let's put in the parameters. So we have 5s4 over root of u. All right, and then the x now is du over 5s4. All right, so this take off this automatically, and then we have 1 over square root of u du. Right, so this, when you integrate this, let's change the root to half. So we have 1 over u power half du. All right, and so u power negative half du. All right, we are changing this to from fraction to linear. All right, so this, when you integrate this, you are going to have 2 u power half plus c. 2 u power half plus c, because when you add 1 to this, it's going to be half. All right, then use half to divide this. It's going to change to 2. All right, so we have half u power half plus c. All right, but then we said u should be equal to x power 5 plus 9. All right, so finally we say that 2 into x power 5 plus 9 all power half plus c. Right, we can change this half to root. All right, so we say 2 square root of x power 5 plus 9 plus c becomes our final solution to this particular integrand. All right, so the integral of 5s4 over root of x power 5 plus 9, the x is equal to 2 square root of x power 5 plus 9 plus c. All right, so now let's move on to question number 6. Question number 6. Question number 6. Question number 6. All right, so question number 6. We are to evaluate this definite integral. We are to evaluate this particular definite integral. And this integral, the integrand is an absolute function. All right, it's an absolute function. So to evaluate this integrand, we need to consider the behavior. We need to consider the behavior of the absolute value. We need to consider the behavior of this absolute function. All right, we need to consider the behavior of this absolute function. So the function x minus 1, the function x minus 1, the absolute of x minus 1 changes as the function absolute x minus 1 changes at x equals 1, changes at s equals 1. So we split the integral. We split the integral at this point. We split the integral at this point. So for for s to be less than 1, for s to be less than 1, then the absolute of x minus 1, the absolute of x minus 1 will be equal to 1 minus x. For x to be less than 1, then the absolute of x minus 1 will be equal to 1 minus x. All right. And for x to be greater than or equal to 1, then the absolute of x minus 1 will be equal to x minus 1. Right? So that is, we split the integral into parts. We split the integral into parts. We have split it into when x is less than 1, and that is 1 minus x, and when x is greater than or equal to 1, and that is x minus 1. All right. So now this split can be written as 1 minus x dx plus right. So now we evaluate each integral separately. So we evaluate each integral separately. All right. So when we evaluate each integral separately, then we are going to have the total evaluation of this particular absolute integral. All right. So now let's evaluate each integral separately. So let's take when x is less than 1. All right. So when x is less than 1, then we have this particular function. We can split it into two. So we have integral of this particular function, dx, plus dx. All right. This particular function has been split into two for easier workings. All right. So when you do this very well, you are going to have integral of 1 is x. All right. With respect to x is x. All right. So we have x negative 2, 1 plus s squared over 2. That is negative from negative 2 to 1. All right. So when you simplify this very well, you are going to have 1 minus 2 minus half into 4 over 2, right? And this simplifies to 3 minus half plus 2. All right. So this is equal to 9 over 2. So this is the first part of the integral. All right. The first part of the integral. So let's look at the positive aspects when we split. So we are going to have 1, 2, x minus 1 dx. And then when you do this nicely, that 2, we can split it to 2, right? We can split this particular function into 2. So when we do that, we are going to have 1, 2, s dx minus 1, 2, integral of that. All right. So now, when you integrate x, you are going to have s squared over 2. 1, 2 minus, when you integrate 1, you are going to have x. All right. So you have 1, 2 over here. All right. So this, when you put in the limit, you're going to have 2 over 2, 2 squared over 2 minus half. All right. Minus into bracket 2 minus 1. All right. So this we have 3 over 2 minus 1. In all, we have 3 over 2 minus 1. 3 over 2 minus 1. And that is equal to 1 over 2. That is equal to 1 over 2. So adding this result and this result, adding this result and this result, we are going to have 9 over 2 plus half. All right, and that is equal to 10 over 2. All right, which is equal to 5. Which is equal to 5. So this is the value for the integral of absolute x minus 1 dx on the limit -2 to 2. All right. So that when you evaluate this particular function, this is what you are going to have. All right. So this is the solution to this particular integration. All right. So let's move to question number 7. Question number 7. Question number 7. So question number 7 says we should integrate ln x over 3x dx. All right. We are to integrate this particular function with respect to x. All right. So now we know that we can bring the 1 over 3 out. All right. When you bring the 1 over 3 out, you have ln x over x dx. All right. So when you have this, you can integrate this. We know that this is 1 over x times ln x. All right. And so we have 1 over 3 integral of ln 1 over x is ln x. All right. Times this is a constant. All right. So we have ln x. All right. Plus constant of integration. All right. So this actually tends to 1 over 6 ln x all squared plus c. 1 over 6 ln x all squared plus c. All right. So let's move on to question number 8. Question number 8. Question number 8. We want to evaluate this particular function. All right. 1 to 8. The integral of s power 2 over 3 dx. All right. So to evaluate this, let's change this particular function. Let's change this particular function from fraction to whole. All right. So when you change this, we have this. All right. So when you integrate this particular x power minus 2 over 3, when you integrate that, we are going to have x power 1 over 3 all over 1 over 3. All right. From 1 to 8. Good. So here we can say that 3 goes up, right? We reciprocate it. And we have 3 x power 1 over 3, 1, 8. Now, let's plug in the limit into the function. All right, so we have 3 into 8 power 1 over 3 minus 3 into 1 power 1 over 3. All right, so this simplifies to 3 out 2 minus 1, and that is equal to 3. That is equal to 3. So our final answer to this particular integration is equal to 3. Alright, so the integral of 1 over s power 3, 1 over x power 2 over 3 dx on the limit 1 and 8 is equal to 3. Alright, so let's now move on to question number 9. Question number 9. Question number 9. So question number 9 says if the differential of a function, let's say f of x is equal to a function, say g of x, then the antiderivative of g of x is given as, then the antiderivative of g of x is given as d dx of the function f of x, and that should be equal to the same function. All right, so it means that f of x is the function whose derivative is g of x. All right, it means that this f of x is the function whose derivative is g of x. All right, so therefore the antiderivative of g of x is f of x. Therefore the antiderivative of g of x is f of x. All right, so this is the understanding of this particular problem. If you have differential of a function, say f of x with respect to x, and it's giving you g of x, then it means the antiderivative of g of x is that particular function equals the g of x. All right, and then you can say that the antiderivative of g of x, this particular g of x, is f of x. All right, now let's move on to question number 10. Question number 10. Question number 10. So question number 10 says if or let u equals root of x plus 1. All right, we should let u equals root of x plus 1. All right, now we are to check if the function, which of the function is equivalent to that particular function. All right, so now what we have to do is that we have to do change of limits to this particular problem. All right, so here this is the function 0 and 3, right? The x over x root of s plus 1, right? So since u is equal to this particular function root of x plus 1, then we can say that u squared, we are squaring both sides, u squared is equal to x plus 1. Alright, so when you differentiate both sides, here with respect to u and here with respect to x, we are going to have 2u du is equal to 1 dx. Alright, so now we can say that the x is equal to 2u du. Alright, so let's plug in the expressions into the function. Alright, so we have integral from 0 to 3 dx over x times u. Alright, and now we know that the x is equal to this. The x is equal to this, so we can say that we have 2u du all over x u into x minus 1. Alright, into alright, so this particular one takes off this. Alright, and then we are going to have 2 du over x minus 1. Alright, so we have to apply what we call the change of limits over here. So let's say when x is equal to 0, then we can say that u is equal to root of 0 plus 1, and that is equal to 1. Alright, and when x is equal to 3, then we can say that u is equal to root of 3 plus 1. Alright, and that is equal to 2. Alright, so putting in these integrals, we can say that 0 to 3, integral from 0 to 3 dx over x square root of x plus 1 is equal to integral of, when x was 0, we had u to be what? 1. Alright, so we have 1 here. Then when x was 3, we have u to be what? 2. So we have 2 over here. Alright, so we have 2u du all over u squared minus 1. Alright, u. Alright, so this now simplifies to 2u over u squared minus 1, all u is equal to 2 over u squared minus 1 du. Alright, because this take off this, right? So therefore the integral becomes from 1 to 2 du over u squared minus 1. So this particular integration function is equivalent to this particular function. With integral from 1 to 2, the function of 2 du over u squared minus 1 is equivalent to this particular function over here. Alright, so note that when you are given such conditions, you have to apply what we call the change of limits. Alright, so now let's move on to question number 11. Question number 11. Question number 11. So question number 11 says we should evaluate an integral, right, from a limit of -a to a of the function f of x dx, and that should be equal to 0. All right, so let's check the validity of this particular integration function. All right, so we need to determine which function, that is f of x, satisfies the condition. We have been given series of functions, right? So we have to check which of the functions satisfies that particular condition. That is from negative a to a, f of x dx equals 0. All right, so we have to check which of the functions satisfies this particular function. All right, so for any function, this particular function f of x, typically means that f of x is an odd function, because the integral of an odd function over a symmetric interval, around 0 is equal to 0. All right, so an odd function satisfies this particular condition. An odd function satisfies this particular function. F of negative x equals negative of f of x. All right, f of negative x is equal to negative f of x. That is an odd function. All right, so an odd function satisfies this particular condition. So now, looking at the conditions given, the objectives given, we can see that this particular function f of x is equal to 3x minus 2x cubed plus x power 5, right, will satisfy this particular condition. All right, so we say that f of negative x is equal to 3 into negative x minus 2 into negative x cubed plus negative x power 5. All right, so we can also say that it is equal to negative out 3x minus 2x cubed plus x power 5 plus x power 5. So this particular one, we can see clearly that this particular one is satisfying the condition of an odd function, whereas we said that f of negative x should be equal to negative f of x. All right, so this function has satisfied this particular function. All right, f of x equals 3x minus 2x cubed plus x power 5 can be evaluated to meet the condition of an odd function. All right, so this particular function is an odd function. This particular function, 3x minus 3x cubed plus x power 5, is an odd function. All right, so now we are done with this particular function. All right, so we've satisfied that this particular function, 3x minus 2x cubed plus x power 5, is an odd function. So if you have series of functions and you are to testify which of the functions satisfies an odd function, or which of the functions satisfies this condition, right, you have to note that an odd function must satisfy this particular condition. F of negative x should be equal to negative f of x. All right, and that, when you look through the objectives, we can see that this particular function can satisfy or will satisfy the odd function condition. All right. So now let's move on to question number 12. So question number 12 is right. So we want to verify, we want to combine these particular three functions, right? The integral of a particular function f of x from a limit of -2 to 2 with respect to x plus a limit of a function from a limit of 2 to 5 minus a limit of this particular function -2 to -1. All right. We want to combine it to make it a singular function. All right. We want to combine these three integrals to make it a single function. So we need to combine the given integrals into a single integrals. All right. So first, let's break it down. Let's first take the first function. Let's take the first function. All right. So this particular function can be split into this way. All right. This particular function can be split into this. All right. So now putting this into the expression, putting this particular function in place of this, putting this particular function in place of this, we are going to have plus right. So here we need to verify we need to combine the remaining integrals. All right, we need to combine the remaining integrals. So here we can see that this particular limit cancels out with this particular limit. All right. This particular limit cancels out with this particular limit. All right. Cancels out with this particular limit. All right. This particular limit will cancel out with this particular limit. 2, -1 plus 5 and 2. This particular two elements. This one will cancel out. All right. So now So now, combining the remaining limits, combining the remaining integrals, we have -1 by f of x dx. Alright, f of x dx. Because when this cancels out, this particular function cancels out this and this, we are having the remaining to be this particular function. Alright. So this becomes the single, when we combine this particular function, this particular integral, and this particular integral, this is the result. Alright. So we can see that this one cancels out this and this. Alright. Cancels out this and this. So when we combine this particular one, we are going to have what is over there. Alright. So now let's move on to question number 13. Question number 13. So if A is less than or equal to C and is less than or equal to B, then the integral of A and B of the function f of x dx should be equal to this particular function. Alright, should be equal to this particular function minus alright. So we need to verify this is the condition given. Right? This is the condition given. If A is less than or equal to C, less than or equal to B, then they assume that the integral of a particular function from a limit of A to B should be equal to the integral of a particular function from a limit of A to C minus the integral of a particular function from a limit of B to C. Alright? So this, we need to verify if the given statement is really true. If this particular given statement is really true. Alright? So now, first, record that the property of integrals, the property of integrals that is A and B integral of a particular function from A to B should be equal to integral of a particular function from A to C, alright, with respect to x plus of a particular function with respect to x. Alright. However, the given statement, this particular given statement here, this particular given statement here is equal to minus alright. So to confirm this, note that an integral of this particular function, alright, an integral of this particular function, right, should be equal to this particular function, say f of x from c to b, with respect to s. That's the integral of a to b of a particular function with respect to x is equal to a right plus of a particular function dx. Alright, so this is the condition. Alright, this is the condition. So therefore we can say that the integral from a to b of a particular function f of s dx is equal to this particular function minus b to c of a particular function dx. Alright, so this means that the statement given, this particular statement given, is very true. Alright, so if a particular value a is less than or equal to c, is less than or equal to b, then we can say that the integral of a particular function with respect to x from a to b should be equal to the integral of a particular function from a to c. Alright, that's minus the integral of a particular function from b to c. And we already know that the property of integrals, or if you don't know, the property of integrals says that when you have a particular function and integrating from a to b with respect to s, that should be equal to the integral of another particular function from a to c plus the integral of another function from c to b with respect to x. Alright, so that's, if you want to confirm that statement, then this is the procedure. Alright, so upon our proof, we realize that the statement that was given is true. Alright, the statement that was given is true. Alright, so now let's move on to question number 30. Question number 14. Question number 14. Question number 14. Question number 14. Alright. Question number 14. So question number 14 says, given this particular function, right, f of x is equal to negative f(x) plus 7 if x is less than 3, s squared minus 16 if x is greater than or equal to 3. Right? We have to find the limit of f of x as s approaches 3 on the positive aspect. Alright? So now, to find that particular limit, we can know that if they are saying that the limit as s approaches 3 on the positive aspect, s approaches 3 on the positive aspect, then we are going to use this particular function instead of this. All right, because they are saying that x is approaching 3 on the positive aspect. All right, so it means that x is greater than or equal to 3. We are not going to use x is less than 3. X should be greater than or equal to 3, and that will meet the condition of as s approaches 3 on the positive aspect. All right, so now we have limit as s approaches 3 on the positive aspect, s squared minus 16. All right, s squared minus 16. So since s is approaching, or since s approaches a value from 3 on the positive side, s must be greater than or equal to 3. All right, s must be greater than or equal to 3. So we choose this particular function. All right, so now putting in the limit as s approaches 3, we are going to have 3 squared minus 16. All right, and that is 9 minus 16. That is equal to minus 7. That is equal to minus 7. So the limit of this particular function as s approaches 3 on the positive aspect is minus 7. All right, so let's move on to question number 15. Question number 15. We are to find the limit of tan x over x. The limit of tan x over x. So now, let's start by understanding the limits. All right, let's start by understanding the limits. All right, so the function tan s can be approximated by x when x is very close to 0. All right, this particular function tan x can be approximated by x when s is very close to 0. All right, so this is because tan x and x behave very similarly near to 0. Tan x and x behave similarly very close to 0. All right, so we can say that, or we can use the small angle approximation for tan x. We can use the small angle approximation for tan x. So therefore, we can say that tan x over x is approximately x as s approaches 0. As s approaches 0. So now we say that tan x over x is approximately x over x, and that is equal to 1. And that is equal to 1. So therefore, the integral of the limit of tan x over x as s approaches 0 is equal to 1. The limit of tan x over x as s approaches 0 is equal to 1. All right, so let me go over this particular problem again. So the function tan x can be approximated by x when x is very close to 0. This is because tan x and x behave very similarly near to 0, right? So we can say that, or we can use the small angle approximation for tan x. All right, we can use the small angle approximation for tan x, and then tan x as s approaches 0, tan x as s approaches 0, we can have tan x over x, and that's approximately x over x, right? And that is equal to 1. That is equal to 1. So now, let's move on to question number 16. Question number 16. All right. We are to differentiate this particular function. We are to differentiate this particular function. E power x sine into ln 2x plus e power cos x. All right. We are to differentiate this particular function. Y equals e power sine into ln 2x plus e power cos x. All right. So this to compute this derivative, we use the product rule and the chain rule. We use the product rule on this particular functions because there are two functions multiplying over here, and then there is only one function over here. So we use the quotient. We use the chain rule on this particular function. All right. So now the derivative of the first function, which is e power x sine into ln 2x. All right. The derivative of this particular function is e power x sine into ln 2x. All right. And that is equal to following the product rule, that is equal to e power x sine into ln 2x, right? E power x dx into sine into ln 2x. All right, into sine into ln 2x. All right, so using the chain rule for sine into ln 2x, we are going to have so using the chain rule for sine into ln 2x, we are going to have d dx into sine into ln 2x. All right. So differentiating this particular function, we know that when you differentiate sine, you are going to have cos x, right? You are going to have cos, all right, into that particular function inside. All right. Then we differentiate the inner function, which is the ln 2x. All right. So we have cos into ln 2x times 2 over 2x. You know that when you differentiate ln 2x, you have 2 over 2x. All right, it's the same as differentiating ln x, and that is equal to 1 over x. Right? you differentiate what is inside, and then you take 1 over the function inside the lane. All right. So here we are going to have cos into lane 2x all over x, because these two will cancel these two. All right. So the x e power x sine into lane 2x, right, is equal to e power x sine into lane 2x plus e power x times cos into lane 2x all over x. All right. So the derivative of this particular function, the derivative of the first one using the product and then the chain rule, we have obtained this particular solution. All right. So let's look on the second part, where we have the e power cos x. E power cos x. So the derivative of e power cos x, the derivative of e power cos x is equal to differentiate the exponential function, right? When you differentiate the exponent, differential of course is negative sine x, right? Then you write the function back again, right? So we have e power cos x. All right. So this becomes the final solution to the differential of e power cos x. So combining the two obtain this and this, combining the two, we are going to have dy dx or e prime, dy dx or y prime is equal to e power x sine into lane 2x plus e power x cos into lane 2x all over 2x, right, minus sine x e power cos x, sine x e power cos x, and that becomes our final derivative to this particular function. That becomes our final derivative to this particular function. E power x sine into lane 2x plus e power x cos into lane 2x all over 2x minus sine x e power cos x. So this is the derivative to e power x sine x into lane 2x plus e power cos x. This is the first derivative to that. All right. So now let's move on to question number 17. Question number 17. Question number 17. So we are given this particular function, f of x, right, is equal to s squared plus 1 power 8 plus 8 power s squared plus 1. All right. So we are to differentiate this particular function on the board. All right. f of s equals s squared plus 1 all power 8 plus 8 power s squared plus 1. All right, so finding the first derivative of this particular function, we have to apply the chain rule to both terms. All right, we have to apply the chain rule to both terms, this particular term and this particular term. All right, so now the derivative of s squared plus 1 all power 8, the derivative of s squared plus 1 all power 8, we are taking the first term, all right, should be equal to, we know that using the chain rule, we bring the exponent down and then subtract 1 from 8, all right, so you have 8 into s squared plus 1, right, power 7. Then we differentiate the function inside. When you differentiate s squared plus 1, we have 2x, all right? You know that s squared plus 1, differentiate s squared, you have 2s. And the differential of a constant gives us 0, all right? So now, let's also differentiate the second term. Let's differentiate the second term. But then let's simplify this, right? Let's simplify this. We have 16x, this and this, we have 16x into s squared plus 1 all power 7. All right, let's differentiate the second term as well. All right, so the derivative of 8 power s squared plus 1, 8 power s squared plus 1 will be d dx of the function, d dx of the function 8 power s squared plus 1 will be equal to ln 8, all right, ln 8 d dx into s squared plus 1, all right, and that is equal to, when you differentiate the s squared plus 1, we are going to have 2x, right, plus 0, and that is 2x, right? Then we have ln 8, right? We have ln 8. Then we bring the function back. We bring the function back. So right, when you differentiate that particular function, we are having 2x ln 8 times ln 8 times 2x ln 8 times 2x times 8 power s squared plus 1. All right, so now let's combine the two. Let's combine the two results. Let's combine the two results obtained. Let's combine the two results obtained. So now, combining this particular derivative and this particular derivative to have the first derivative of the function on the board, we have the first derivative of f of x, and that will be equal to 16x into s squared plus 1 all power 7 plus 2x ln 8, 2x ln 8 times 8 power s squared plus 1. All right, so this becomes our first derivative to this particular function. All right, so now let's look at question number 18. question number 18. We are to find the first derivative to e power cos x, e power cos x. So now let's u equals cos x. All right, let u equals cos x. So when you differentiate u with respect to s, you are going to have minus sine x, right? Now let's make the x the subject, right? So when you make the x the subject, then you are going to have the x is equal to du over sine s. That is negative, right? So now let's substitute the u in place of the cos, right? So we have u, y is equal to e power u. All right. Now we know that when you have a function like this, when you differentiate the function on the top, then use it to multiply the whole function again. And then over here we have differentiated the u already, and we had negative sine x. All right. So we have negative sine x, negative sine s times e power u. All right, we have already differentiated u over here, and we had negative sine s. So we just bring it there, and then we write the function again. But then earlier on we said that u should be equal to cos x. So we have the first derivative of e power cos x as negative sine s e power cos x.